Sketch the following graphs. Show asymptotes as dashed lines. Identify at least 2 points on each graph. Label either the points or the axes for proper scale. All right, first off, we have an exponential. I can tell it's an exponential because we have an x in the exponent, and then we have a log. Clearly it says log. Sometimes the ln is misinterpreted as an in. That's nothing that we have in mathematics. This is a lowercase l. There is a nice kind of way to remember the basic shape based on these words. And that's essentially the shape that we're going to see as we graph this. What's important about the exponential is one side's going horizontal. Sometimes it's right, sometimes it's the left. And the other side's going off to up and off to an infinity. And the log, one side's going vertical, while the other side is going to a horizontal infinity, right or left. Okay. For the exponential, the horizontal asymptote, there we go, is a y equals, and it's always the constant term. If you don't have a constant term, it's equal to 0, because you always have a constant term. Just sometimes you don't see it. So we have a dashed line necessary at -2. I'm going to write y equals -2 because I notice that there are no scale markings on here. So right now you wouldn't be able to tell that's -2. This could be a -20 or -200, -400. It just depends on the scale. But now I've labeled y equals -2, so I know the y-axis scale is just by ones. Okay, next up I'm going to go after the anchor point for this one, and that is if I can pick an x value that leads me to an exponent of 0, then it's nice when you have an exponent of 0 because it doesn't matter what the base is. For example, -3 to the 0 minus 2, well that's all in the, that's not good. There we go. Minus 2 is -3. What's important about the power to the 0 is what the base is. This is the base exponent pair. 3 to the 0 is 1. So that's -1 minus 2, which is -3. 0, -3. That point is well established. We have the y scale labeled. We don't need to, we'll need to scale the x-axis eventually, but not yet. And then I'll put another value in there. Let's try 1, something close to the previous point. -3 to the 1 minus 2 is -3 minus 2 is -5. So -3. Now I have to write that -3 and -5. Okay. That's not -3, -5. Whoa, my brain just stopped. I'm so sorry. 1, -5. That's better. That's 1. 1, 2, 3, 4, 5. What was going on in my brain? I will never know. There we go. Sketched. Like an exponential function, one side's going horizontal, while the other side's going off to an up or a down infinity. For the logarithm, we have a little bit different issue. We have some facts about logs. First off, I'll do this in base 2, since that's what we have. Log base 2 of x, the domain, is x is greater than 0. Something crazy happens at 0. Specifically, log base 2 of 0 is undefined, and it has to do with the vertical asymptote. It's not the vertical asymptote, but I'll explain. Another fact that's important, log base 2 of 1 is 0. It's just a very nice fact. Log base 5 of 1 is 0, etc. And then I will utilize log base 2 of 2, which equals 1. Just some nice facts about logarithms. Okay, now in this problem, what's inside the log is x minus 2. So I want to actually work with x minus 2 equals 0, x minus 2 equals 1, and x minus 2 equals 2. And I'm just picking those from the 0, 1, and 2, and it's the inside of this function that needs to be equal 0, 1, and 2. What this is giving me are some values. For example, x equals 2 is the vertical asymptote. So let me label this with an x equals 2, vertical asymptote. And then x equals 3, I'm going to plot points. Give myself some room to work. There we go. Using 3 and 4, the two values that I just generated, and it's going to give me these nice facts that I know about logs. This would be log base 2 of 3 minus 2 is 1. That's 0. And log base 2 of 4 minus 2 is 2. And that's 1. So we have 3, 0, and 4, 1. We label that scale x equals 2 labels the x scale, but you can go through and label that one as well to make sure. And we have this shape, which is the great log shape, the most basic one. One side is going vertical, while the other side goes off to a right or left infinity. Now let's look at the instructions, make sure we get full credit on this one. Sketch the following graphs. Show asymptotes as dashed lines. Check, check. Identify at least 2 points on each graph. Oh, we need to identify points. So this was 1, -5. This is 0, -3. Label either the points, labeled, or the axes, which I also did, for proper scale. This is 3, 0, and 4, 1. Now we get our full credit. We've done everything they asked for. All right, hope this makes sense.